Hello everyone! In this video I'm going to show you how to keep the aspect ratio of a 2D shader regardless of its sprite size. So let's say that I have this shader which draws a circle mask on my texture rect. It works fine when my rectangle's height is equal to its width, but the moment I scale the texture the issue is obvious, the shader scales as well. Now, if you look for a solution online, the first thing you'll probably find is that you should pass the texture size in a vector to uniform and use that to find the aspect ratio. Knowing the aspect, we can center the UV in 0, 0, divide uv.x by that ratio and then move the UV back to get our improved shader. Oh, and if you're wondering why I'm doing the -0.5 plus 0.5, here's what Cashew has to say about it. At first, it might look pointless, but that's how you choose where the scaling happens. The UV coordinates live in a 0, 1 box with the origin 0, 0 at the top left corner. If we only scale the UVs, the scaling always happens from that corner because multiplying anything by 0 returns 0, keeping that point in place. So, to scale from the middle, we'll shift the center of our UVs to that 0, 0 coordinate by subtracting 0.5, 0.5 from it. After scaling, all that's left to do is to move back the scaled texture to where it started. Alright, but now that we set this up, all we have to do is to go to our texture, copy its size and place it on the texture rect size uniform. The circle is now perfect. Though, if I have to change the size of my sprite, I again have to go pick its size and paste it into the uniform. To avoid this, instead of passing the size, we can make use of the FWidth function. Now, the FWidth function returns the rate of change of some values that we pass in, so in our case we could use it to find the rate of change of our UV. Now, what does that even mean though? Imagine we have a sprite that's 2 pixels tall and 4 pixels wide. Its UV would still range between 0 and 1 and provide the coordinates of each pixel, but because of the size difference between axes, the UV values change faster for a single pixel on the y-axis compared to a single pixel on the x-axis. For example, a single pixel covers half of the UV representation vertically, while horizontally it covers just a quarter. So, in other words, the rate of change for the x-axis is 1 over 4 and the rate of change for the y-axis is 1 over 2. These numbers are pretty much what we get if we use the FWidth function. Now, the interesting part is that if we were to divide the x and y of the result, we'd get 1 over 4 divided by 1 over 2, which is equal to 2 over 4, which is exactly the inverse of our aspect ratio. So, back in our code, we can use FWidth of UV to get the rate of change for our UV, and then because we get the inverse of our aspect ratio, instead of dividing the x and y of the result, we'll divide the y and x. Everything else stays the same, but now we no longer have to use the texture size uniform for our circle to keep its original aspect ratio. Now, one thing that this shader still needs is to be a bit more general. Right now, the shader assumes that the y-axis is smaller than the x-axis. I did this intentionally to keep the explanation simple, but if I resize the sprite to be taller, you'll see that the circle still stays round, but gets scaled, which is inconsistent with how it doesn't get scaled when the sprite is wide. To remove this assumption, we have to find which of the rates of change is larger, we need to get a new aspect ratio based on that, and when scaling we need to apply the obtained aspect ratio on both axes. It's really a simple change, but now we have consistency on both axes. Alright, I hope this helps, thanks a lot for watching, thanks a lot to my supporters, and see you in the next one. Bye bye!